Hi there, welcome to lesson 2.4b, where we're going to be solving equations with variables on both sides and multi-step. The difference today is we're going to be looking at a couple of special cases. In our first example, you can go ahead and write it down, and I just want you to start to solve it like you would solve a typical multi-step equation. Distributing on this side, 2 times 6, and then over here, bringing this down. Now notice something. 10x plus 12 is equal to 10x plus 12. They're exactly the same. Let's just take a step back real quick. I want to draw what this equation looks like on a balance. Because if this is equal, you can kind of think of like this expression being on a balance and being equal to each other. So 10x's plus 12. So here I have 10x's, and then I have a 12-pound weight. On this side, I've got two groups of 5x plus 6. So here's 5x's and a 6-pound weight. And here's another group of 5x's and another 6-pound weight. Hard to kind of see that x right there. Now, take a look at the balance. Right now, these two things are equal to each other because it says they are. Imagine plugging in any number in here for x. Like imagine if all these x's were 3. Wouldn't both sides be balanced? Yeah, and imagine if all of the x's here were 5. Both sides would still be balanced. And even if all the x's represented the number 4, both sides are still going to be balanced. Over here, imagine plugging any number in here for x. If you plug the number in here for x, multiply it by 10, and then add 12. Wouldn't both sides always be equal? Absolutely. This equation has a special name. It's called an identity, because it's identical on both sides. Remember the identity property? There was one for multiplication and for addition. Both are identical. So this equation is called an identity. This equation has infinite solutions. Any number could be a solution to this equation. So it actually has infinitely many solutions. Now let's continue solving here. Like let's say I was going to go ahead and minus the 10x because I need to move it to one side. So if I minus 10x, they're going to both cancel. They make 0. And I end up getting 12 is equal to 12. Again, another identity. But the x cancels out and I literally can't even solve it for x. Okay, I get an identity. And this equation has infinitely many solutions. Okay, let's look at another special case. Go ahead and write down the equation. And we're just going to solve it as we normally would solve an equation. Again, over here, we'd want to distribute. And 2 times 1 is 2. Over here, I just bring this down so everything's on the same line. Now the next step here would be to move the variable to one side or the other. Again, just like the last one, these two are exactly the same. Remember the last equation, both were 10x. They're the same. That's going to kind of give you a clue that this is a special case. There's not one bigger side. Let's just take a step away from the problem and let's draw what this would look like on the balance. Here I have 4 x's and a negative 5-pound weight. Over here on this side, I'd have two groups of 2x plus 1. So I'd have a group of 2x's and a 1-pound weight, and I'd have another group of 2x's and another 1-pound weight. Now it says that these two are balanced. Now there's the same number of x's. So imagine if you plugged in a number for x. Like let's say I plug in the number 1 for all these x's. Is it going to be balanced? No, this side's going to be heavier. If I plug in a number 10 for all of these x's, not balanced, this side's going to be heavier. I mean, if I plug in any number for all of these x's, you see how the value of the x's will be the same. But because of this, this side will always be 7 pounds heavier, won't it? Nothing's ever going to balance it. So let's go over to the equation. I notice here that both of the parties, or 4x and 4x, are the same. Let's just continue solving it like we would, where we would just say, okay, I'm going to minus the 4x, I'm going to try and move to one side. But the problem is 4x minus 4x makes 0, and it also makes 0 over here. The x literally cancels out, and you can't solve this for x. So let's drive this down. -5 and +2. They don't equal each other. -5 is never equal to +2. They don't equal each other. So that right there tells you that these two can't be equal. Let's go back up into this part right here. Imagine if you plug any number in for x, multiply it by 4, and then if you subtract 5 over here and add 2 over here, this side's always going to be 7 pounds heavier. There isn't any value for x that you could plug in here that's going to make both sides equal to each other. This equation has no solution. So this is another special case, no solution. Okay? So we're going to see equations where there's infinitely many solutions and equations where there's no solution. All right, let's try a few, see if we can figure it out. So sometimes we're going to have a solution like we normally do, like, a equals something. Sometimes we'll have no solution, and sometimes we'll have infinitely many. Let's see what's going to happen here on this one. So go ahead and copy it down in your notes. There might be part of it missing. Looks like we're going to have to distribute and combine like terms. So if you remember this mnemonic device, don't call me after midnight, distribute and combine like terms have to happen first before we move the variable. So think half of 6, half of 4a. Over here, it looks like I'd have to combine like terms. -4a plus 6a. Okay, now let's see what we have here. 3 plus 2a equals 2a plus 3. Wait a minute, they're the same. What kind of equation is this? Yeah, it's an identity. They're identical. At this point, you probably know what the answer is. You know that you could take any number a, multiply it by 2, add 3, and both sides are always going to be equal. An identity means infinitely many solutions. So I would say a equals infinite solutions. Sometimes you'll see infinitely many solutions as well. Sometimes kids will ask me, can I just write IS for infinite solutions, or the little infinity symbol? As long as you know what that means, that's typically okay. Just be careful when you enter your answers into backpacks. Infinitely many solutions. We're not going to say that this is an identity. That's the kind of equation it is, but our answer would be the fact that a could be anything. I mean, even if I took it a step further and minus the 2a from both sides, you see how I can't actually solve for a equals something. I still get 3 equals 3. So I still get an identity. It's still infinitely many solutions. All right, let's try this multi-step equation. Go ahead and write down the rest of it. Looks like we got some distributive property, cleaning things up around here. Distributing here. Remember, we're distributing a -2, so I'm circling that. The 16 gets dropped down. -2 times x. -2 times 5. Okay, now that's just the distributive property, but now I need to combine any like terms that I might have. And I can see here I have acquaintances that need to come together. So 16 take away 10, I'll have -2x, and then these two together would make 6. All right, now I'm going to look to see that I have a variable on both sides. I have a 12x here and a -2x here. Is this going to be a special case? No, they're not the same. I have to pull this and bring it to the bigger side. So that makes 0. 12x's plus 2x's. All right, looks like we're going to get one solution here. 6 minus 6 is 0, divide by 14. X equals 0 divided by 14, which is 0. So my answer here is x equals 0. So if I were to plug in 0 for x to both sides, I would have a balanced equation. 0 is the solution. This one only has one solution this time. All right, on number 3, we are trying to find the value of n. Holy buckets, look at all those n's. All right, let's get ready. It doesn't look like I have any parentheses, so I'm not distributing. I'm going right down to combining like terms to clean this up. -7n plus 8n is just 1n. over here, cleaning this up over here. Negative 1 plus 2 is just 1n. All right, now I notice I have a variable on both sides. Oh, they're the same, 1n. Aha, special case. Well, think about it. If you plug any number in here for n, add 8 over here and 6 over here, this side will always be 2 bigger, won't it? Nothing's ever going to balance this. Even if I continue the process and move the n, do you see how it cancels out? Special case. Now it says 8 equals 6. That's never true. 8 never equals 6. Not true. No solution. Not true. Okay, no solution there. You can think of it that way too. Not true, no solution. N cancels out. And we can see just by looking at it, there's no way this is ever going to be equal if we plug in any number there. All right, let's try 4. What's going to happen with this one? Are we going to get one solution? Are we going to get no solutions? Are we going to get infinitely many solutions? I don't know. Looks like on the left-hand side, we're going to need to combine like terms. Over here, we're going to need to distribute and then combine like terms. 7m, take away an m. Bring down the plus 16. Here we're distributing a negative 4. Careful, the negative comes with the 4. Negative 4 times m. Negative 4 times negative 4 is a plus 16. Now I still need to combine like terms on this side. Here's 6m plus 16. Stop. Do you see something? The m's are identical. The coefficient is the same. That tells you it's a special case. Let's check it out. 6m plus 16. They're identical. Do you remember what that means? Yes, think if I plug any number in for m, multiply it by 6, and then add 16, they're always going to be equal. M could be anything. Even if I continue and minus the 6m, they cancel out, and I get 16 equals 16, which is another true statement. It's an identity. This is identity, this is identity. So, therefore, m equals infinite solutions. Infinitely many solutions. Now it's an identity. I get infinite solutions. They both start with an I. You can think of it that way. But any number is going to work for this. Infinite solutions. Okay, copy the rest of this equation. Let's check out and see what happens here. What are we going to get for f? Are we going to get one solution? Are we going to get infinitely many, or are we going to get no solution? Let's check it out. Looks like on the left-hand side here, we're going to need to distribute here, and then we'll probably need to combine some like terms before we move the f to one side. So we're going to distribute the negative 4. Drop down the 13. Negative 4 times f. Negative 4 times negative 2 plus 8. So here we go. I got a 13 and a plus 8. Looks like I've got some acquaintances to connect together. So we got 21 minus 4f equals negative 3f. Okay, now I'm at the point that I've done the distributive property, I've combined like terms, now I get to move the variable. I've got a negative 4f and a negative 3f. Which one's bigger? Which one's closer to 0? This one's bigger. Let's move this to the bigger side. Do you see how if we add 4f to both sides, I'm going to get a positive over here? Try and get a positive. So this makes 0. Negative 3 plus 4 is just 1f. I don't need the 1 in front of it. And then I bring down 21. I got one solution. See, just by these two being different coefficients on the f, that tells me I'm going to get a solution. It's not a special case unless these two are the same coefficient. Boy, we've been solving lots of equations. Here's our last one. We've got combining like terms here and distributive property here. Go ahead and start to simplify. Let's see what we've got going on here in this equation. I can tell there's a c on both sides, so we're going to have to move the variable. Negative 9 plus 10. Half of 2c. That's just a c. Half of negative 24. Half of negative 24 is minus 12. Okay. Do you notice you have a c on both sides and they have the same coefficient in front? They're both a 1c. That tells you this is a special case. It's going to either be no solution or infinitely many solutions. Well, which one's it going to be? Are they exactly the same? Are they identical? Are they an identity? No. Okay, they're not. Think about if I plug in any number for c. If I add 12, I plug in any same number right here for C, same number, right? Let's say I put a 10. If I add 12 over here and take away 12 over here, this side is always going to be 24 bigger. So let's continue solving it. What if I were to minus the C? Do you see how it cancels out? And I end up with 12 equals negative 12. Not true. No solution. Think of the words not true. No solution, right? So answer for C. C equals no solution. Yep, can't figure out C. There's no number C that's going to ever make these two sides equal. Doesn't work. So just to recap here, when we're solving multi-step equations, we may end up getting infinitely many solutions. And that would be in the case where, again, I see that the A is on both sides. It has the same coefficient. It's identical on both sides. It's an identity. So infinitely many. Think identity, infinitely many. Okay, exactly the same. All right, as I'm solving equations, I may also get the answer of no solution. So in that case, notice here how, again, the n was on both sides. It had the same coefficient, so I knew it was a special case. There's no number that's ever going to make this true. In this case, this is always going to be 2 bigger. If I minus the n, I get something that's not true. Okay, so think not true, no solution. And in both of these cases, if I were to subtract and move the variable to one side or the other, it's going to completely cancel out. Then we also see equations where we get one solution. And in this case, we got one solution. We were solving it. We noticed here that we had negative 4f and a negative 3f. The coefficients of the variable on both sides were different. So we went to the bigger party and we were able to solve. So in some cases, you'll get infinitely many solutions. Some you'll get no solution. And then sometimes you'll still get one solution like you're used to seeing. Thank you so much for joining me on Lesson 2-4B, where we were solving multi-step equations with special cases. Have a great day.